Okay, I think we will just make a start. If people are joining over the next few minutes, it won't make too much of a difference. So welcome to this afternoon's session. This is session 2 in the programme. And this afternoon we are going to be focusing on number and number processes. If you've joined just there and you didn't hear me already say, could you please take a few minutes just to complete the short pre-course survey if you weren't at session 1. You can scan the code or you can use the link on the slide, and we will put the link into the chat just a little bit later on in the session, so that if you haven't had a chance to do it at the beginning, you can do it then. Iona, can you just move on to the next slide for me, please? Thanks. So this afternoon's session is being recorded, and the link to the recording will be added to the Padlet as soon as it's available. Can I ask that during the presentation you keep your cameras off and your mic on mute, and this will help with the connection quality. We're using PowerPoint Live, and before we get started properly, I'm just going to run through some of the accessibility features available in this. So firstly, if you look underneath the slides, you'll see that there are some arrows and the slide number, and you can use those arrows to navigate back and forward through the slides without it impacting on anybody else's view this afternoon. So if you've missed something and you just want to check back, then you can use that arrow to do that. Just beside where the arrows is, there are 3 dots, and if you click on that, then that will allow you to view the slides in high contrast, and then you might find this a useful way to improve the clarity. If you go to the 3 dots beside the video icon and click down, a drop-down menu will come down, and you can use that to improve your view using full screen or zoom, and you can also turn on the live captions. During the session, you can make comments or ask questions using the chat function, and if we've got time for a live question and answers towards the end of the session, then we'll invite you to use the hands up function. If you're having any problems either with the sound or with access to the chat or with viewing the slides, then in the first instance we would recommend that you leave the meeting and rejoin. Usually this fixes the problem. It's a bit like the old adage of switching it off and switching it back on again. Finally, you'll see a take control button just at the top of your screen, and we would ask that you please don't click on that. If you do, then it's likely that this will cause everyone to lose access to the presentation. Okay, thanks, Iona. So just an opportunity for us to see or to check that you're able to access the chat and that you are hearing us all right, and also just for you to take a little bit of time and share something with us. So during the session today, we are going to be referring to a number of manipulatives, and we've put some of these on the screen. So what we're interested to know is how many of you have already used these. So I'm going to post a poll, and what I'd like you to do is just click on the ones that you have already used in a class. So the poll should just pop up in the screen in a minute. Iona, did the poll come up?
Yes, it did. I'm Excellent. Just replying to somebody who's struggling with sound, so I'm just going to put in the chat for them to see about leaving and rejoining if they've not heard that. So I'll just be a second with that.
Okay, so if you just click on the ones you've already used in class, and the results should begin to pop up in the chat. Please don't worry if you haven't used them yet. What we're hoping to do over the session tonight and over the next series of inputs is to give you ideas of how you can use them. Yeah, and some of you may not have had the actual concrete materials, but you may have used a digital version. And if you've used digital double-sided counters or digital algebra tiles, please free to click on the fact that you've used them with a class. MathSpot is an excellent source of digital manipulatives. I think we mentioned that in session 1, and we will refer to it quite frequently through the sessions. Great, so it looks like the most popular one so far is Algebra Tiles. That's good to see that quite a lot of you have had opportunity to work with some. Okay, thanks for that. Moving on to the aims. For those of you who attended session 1, we shared our reasons for offering these sessions, which you can see here. So just a reminder today that this really is a safe space for us to explore effective approaches to learning, teaching and assessment within numeracy and mathematics, and that we hope that this gives you a chance to reflect on and strengthen your own practice. And this is us, myself, Nanette Brotherwood at the top, and I'm joined this afternoon by my colleagues, Iona Coates, who's just come on camera, and Stephen, who's also there, and they will be speaking to you later on in the sessions today. A quick reminder also that we have set up regional teams to allow you to network with colleagues and to share practice and resources. The joining code for each of the teams, sorry, my cat's just decided to join us this afternoon, is there on the screen. And we've also organised some regional drop-in sessions to support the conversation around the national webinars, and you'll find details of when these sessions are on in the particular teams within the teams themselves. You can join the team by using the link in the slide, which takes you to a page which then has a link to join a team using a code. You'll need to be logged on to Glow to do this, and you'll need to be logged on to Glow to participate in the team. But remember that even if your local authority doesn't routinely use Glow, you will still have a Glow account, and you should be able to get some support at local authority level, or get in touch with us if you need some extra support in how to access that. Okay, so at the beginning, when I was talking about accessibility, I mentioned using the chat to communicate with us. There's 2 ways that you can comment or ask a question. And the first is, of course, within the Teams chat, but that chat disappears at the end of the session. So, you know, in order to capture and continue the conversation, then we've put together a Padlet which you can use to ask questions, and that will be available throughout all the sessions. So if you use the link at the bottom of the slide, either to click through onto the Padlet on the machine that you're on just now, or if you want to go onto it just using your phone, you can use the QR code. And when you go on, if you double click anywhere in the green background, you can add a question. You can then resize it and reposition it after you've published it. If your question's about today's session, then put it into the car park side of the Padlet, and we'll talk about it before the end of the session. If you've got any burning questions of topics that you'd like to cover in future sessions, or something you would just like to hear others' opinions about, then pop them over towards the big questions side of the Padlet. You can add likes and comments to the posted questions, so please feel free to do that too. Now, we've highlighted here a question that was posted in the Padlet during session 1, And what we'd like you to do is just take a few minutes to see if you can link into the Padlet and you can have a look at it. And if you've got something that immediately comes to mind that you want to put in response to that question, then please just add that in. Or if you think about something during the session today, or then again, please add that in. We will come back to the Padlet in the middle of the session and again towards the end, and share if there's been any responses to that question, and also answer any other questions that have come up if they're suitable for today, or just anything that needs discussion. Okay, so I think I am now handing over to Stephen, who's going to take you through the next section of the presentation.
Hello, Nanette. Am I here?
I can hear you, yep.
Thank you. Hi everyone, this afternoon we're going to focus on our number and number processes publication, and there's a link there that you can see to our professional learning resources. We're going to look at the models of subtraction and division, the grid method and its applications, integers, and how we can continue generating relevant problems for third and fourth level learners. We know from those that carried out the pre-course survey last week that some of you are actually teaching or supporting learners at early to second level as well. And what we will do is we'll add the PDFs of their slides and the recording of their webinar to our regional spaces, and that you can have a look at and use as well. Thanks, Iona. One of the key themes within the professional learning resources is the continued use of concrete materials and visual approaches to support learning and teaching at every level. You'll see a link here to MathSpot, which I'm sure some of you are already using, especially as someone said in times of COVID when you can't use physical materials. The site offers you visual representations which are useful for whole class teaching and will save you sourcing or making your own concrete materials yourself. As you can see, the resources include double-sided counters, which can be used to illustrate integer arithmetic, algebra tiles for expressions and equations, base 10 Dean's materials, which will be commonly recognised by your learners coming into first year, prime factor tiles, Quiznaire rods, which you can use for ratio, proportional reasoning and other number concepts, and finally place value counters, which have the benefit of extending the concept of Dean's materials into decimal fraction place value. Our first focus today is two types of subtraction that your learners will come across in their school careers. If we consider these two word problems for subtraction, let's think about how they're different and how they're the same. I'll give you a wee minute to read them. Learners might use manipulatives like we're shown here from MathSpot to help with these calculations, and the calculations themselves can look quite different. In the first case, they can literally take away, let's use the terms subtrahend from the minuend to get the answer. In the second example, you'll see that the minuend and subtrahend more represent two separate quantities that are to be compared, and where we would expect learners to find the difference to get the answer. Your learners would benefit from understanding that both approaches can be used to interpret subtraction problems, depending on what they're more comfortable with. We should consider whether we offer enough of a variety of questions so that learners get a solid understanding of both types of subtraction. Think about whether your learners find one type harder than the other, whether the two methods are related, and we'd ask you that if you have come across this and used the both methods, that you can put your thinking into the chat for others to read. Something else that learners might use is a visual approach, such as an empty number line to help with their calculations. Different strategies would result in the same answer. For example, in the first context where we're taking away, it lends itself to counting backwards. As you can see here, we're carrying it out in partition jumps to get to the answer. And in the second context where we're finding a difference, it lends itself more to counting on using the same technique. And you'll see those jumps again in being partitioned into more simple examples. Number lines can be continued to use to help learners perform more complex calculations using partition jumps. The more complex the calculation, the greater the variety of strategies you might see them using, and these different approaches can be used and encouraged by first tackling fewer calculations, but in a variety of ways through small group and whole class discussions. Bar models can also be used to illustrate these contexts in a way that invokes a sense of spatial reasoning. In both examples that you see here, the same partitioning is being carried out. However, again, we can see that in the first illustration, we would remove 12,500 and determine what is left. And in the second, we would compare the two quantities and find the difference. This experience of a spatial view of subtraction is really helpful when tackling, for example, problems of perimeter and area of irregular shapes where missing lengths need to be calculated. Something that we understand that many of our learners struggle with, even up into the senior phase. We've produced a number of mini guides for pedagogical approaches in our professional learning community that Nanette mentioned. And here there's a link to our overview of bar modelling. And if you're interested in finding out more about this approach, you can click on the link after today's session. Thank you. Some learners might use concrete materials to help with division and might display different strategies to find the correct answer. Sharing versus grouping will affect how your learners count. For example, when sharing here, they might do 1 to you, 1 to you, and so on between the 4 sets, whereas with grouping, they are likely to repeatedly count to 4 within the 5 different groups. Continued practice of these methods, firstly with simple division like we've shown you here, before moving on to complex problems, might help some learners if they struggle with tackling division problems. Again, beyond concrete materials, bar models, as you'll see, can be used to illustrate both those models of division, and you might find that this is preferred by your learners working at 3rd and 4th level. Thanks, Iona. Continued practice and application of the 4 operations can help you cement learners' knowledge and understanding. You can structure retrieval activities such as quick quizzes, homework exercises, and low-stake assessments in a manner that ensures everything is revisited. For example, choosing questions that check up on what was covered last week, last session, last month, and last term. Flashcard activities for quick recall or mental calculations can help build fluency. One approach is to do a round robin, with each learner creating a flashcard with a question on one side and an answer on the other. They can then move these around the class, attempting the different questions in pairs. This gives them an opportunity for peer assessment, peer discussion, and also for learners themselves to learn through creating problems. Another option that you might see used is bingo. You could offer, for example, 16 answers, and the learners choose 8 of them on their mini whiteboards. You can then flash up corresponding calculations, and they score off the correct answer if they have it, and so on. You can extend this activity by asking learners to write down different calculations and swapping them so that they have to actually work out the calculations as well as match your answer. Thanks very much for now. I'll pass you over to Nanette.
Thanks, Stephen. So lots of information there in quite a short period of time, and we're now moving on just to the to look at another possible method that you might want to explore. So we're starting with the grid method. You'll find that it's exemplified in the professional learning resource throughout 2nd level. But what we're going to do this afternoon is take a look at how the method could be developed to support the understanding of the distributive property and linked to algebra. So as learners develop their understanding of multiplication, they will have been encouraged to use known facts and to explore ways to perform the calculation. So further development can then lead to the use of what's called the grid method. So this model will help learners to develop the understanding necessary before they move on to the standard algorithm. And it will also reinforce the distributive property. So the grid method for multiplication and division builds on learners' understanding of arrays. It's easily extendable to cover long multiplication, which we'll show you an example of later, and also multiplying decimal fractions. And it can bridge the gap between using concrete materials, number facts, mental methods for simpler division, and the algorithm for dividing larger numbers. You'll find lots of examples of this within the professional learning resource, and if you want to know exactly where, it's round about pages 34 to 36 or 37. So let's consider 132 multiplied by 6. So we can partition 136 so that we've got 3 more straightforward products to calculate. We can then calculate each product and add them together to calculate the total of 132 multiplied by 6. The process could be reversed for division. So if we consider the dividend 792 and we partition it into multiples of 600, 60 and 6. So we would say, how many 600s are there in 792? Rather than how many 6s are there in 7, which often causes confusion and a lack of understanding when we're dealing with division. So how many 600s are there in 792? The answer is 1. So the first part of the quotient is 100, or a 1 in the hundreds column. And then we're left with 192. We don't just have a remainder of 1 as we would have had using that standard method. We have 192 left. So then we ask, how many 60s are there in 192? And the answer is 3. So using up a further 180. And that gives us the next part of the quotient being 30, or a 3 in the tens column. We've then got 12 left, which divides by 6 to get 2. So the quotient is 132. And the process mirrors exactly the division algorithm and gives the opportunity for a visual representation of an abstract process. Learners may move on to use the formal written algorithm for both multiplication and division, but if they're confident with its use, it can provide, or it proves really useful when we move on to working with algebraic expressions. So a simple grid method can illustrate multiplying a bracket by a single term. So we can link back to that grid method, but initially we can model the example using Algebra Tiles, and many of you have said that you've got some experience of them. So here we've got 3 x's and we've got our 3 negative 1s. But we know that we have 2 sets of them. So we can then see that altogether we've got 6x and 8 negative 1s. This can be represented in the grid model as 6x and our negative 8. Thanks, Iona. We can also use the manipulatives to promote the understanding when we move on to factorising. So this time we've represented our 6x minus 8 using our algebra tiles. So first of all, let's see if we can split it into 2 equal sets. And that doesn't quite work because we've got our 2 negative 1s left over. So 2 is not a common factor. So let's see if we can...
Sorry, Nanette, that first one is trying to split into 6. Sorry, it's a bit, it's not clear.
Oh, sorry.
Yeah, sorry.
Mm-hmm.
If we try and divide by 6, we've got that.
Tried, Thanks, Iona. Sorry, not looking at the slide properly.
You can tell it's late in the day, can't you?
You can tell it's late in the day. So in the next one, we're splitting it and trying to split it into 3. And again, doesn't work out. We've still got those rogue 2 negative ones that don't fit in. So in the final one, we're going to split it into 2 equal sets, and this time it does work, and we can represent that in our table as 2 is a common factor, and it splits it into a 3x and a -4. Okay, so returning to the grid method for multiplication, this time we're moving on to an example which illustrates log multiplication. So as I mentioned before, the use of arrays to model multiplication is encouraged throughout the professional learning resource. And learners familiar with arrays could also use Dean's blocks to build and illustrate the calculation. Oh, the animation doesn't seem to be quite in the right order. We should have an illustration in the top corner, but that will come. As already mentioned, if access to actual concrete materials is restricted, then MathsBot, the illustration at the top there, is just put together using the MathsBot website. So building on that concrete representation, we can link it again to the grid format. So even if learners have moved on, after using this as an introductory step, and even if they have then moved on to using the standard algorithm, returning to some examples provides a good lead in to the next stage in algebra when we are multiplying two linear expressions. So we can see in this example that the process here is identical to the previous example where we did 36 multiplied by 12. The product in this case can be modelled using algebra tiles or digital representations of algebra tiles. So again, we've got the x multiplied by each of the 3 x's gives us our 3x squared. We've got the x multiplied by each of our 1's, gives us a 6x. We've got our 2 multiplied by our 3 x's, gives us another 6x. And our final, we've got our 2 multiplied by our 6 1's, gives us 12. Building up to give us our final solution of 3x squared plus 12x plus 12. If you want to find out a little bit more about the use of algebra tiles, I know some of you have said that you have used them with classes, but there's some excellent professional learning webinars by Tom Manners, which were recorded during lockdown last year, with lots of ideas and much further discussion than we've got time to do this afternoon. So I'd thoroughly recommend those 2 links. So a common method that's used in many departments for expanding brackets is FOIL. But this can all break down when we move on to multiplying trinomials by linear expressions. However, by modelling their calculation here, before going on to look at this example, then using the grid method from earlier and continuing to develop it means that we've got a model that can be extended to support this type of example. We can also further extend it to support factorization, and when we move on to higher, it provides a logical alternative to synthetic division when completing polynomial division. So that brings us to an opportunity for you to have a few minutes of a screen break. We've thrown a lot of information at you in the last half hour. So we'd like you just to take 5 minutes to stretch your legs, to look away from the screen, or if you'd like to have a go at the activity that's on the screen just now. So it's 16:32, we will restart at 16:37 and Iona will take you through the next part of the presentation.
Moving on to working with negative numbers, there's lots of different ways to introduce the context of negative numbers. Some of them are in the middle picture you can see here. You may well have introduced them looking at temperatures. As the temperature drops below 0, that'll obviously be very familiar with learners. But we could also have above and below sea level. We could have a ground floor and floors in a building below ground level, and so on. So there's lots of different options, and it's important to help learners see how the concept of negative numbers can appear within a context. Visually, it's very useful to use number lines. That builds on what learners know already about counting on, counting back, using the positive whole numbers that they've learned about before. But we can continue this counting beyond 0. Number lines can be vertical or horizontal, and it might be nice to do a mixture of both. You might actually use a thermometer to start off with, as that might be familiar to learners too. We're going to look a bit over the next few slides at how we can use double-sided counters to illustrate some integer arithmetic. When we're preparing to teach learners about negative numbers, it's worth just taking time to reflect on our own understanding of negative numbers and how we're going to approach these concepts. Are we going to use number lines? Are we going to use them vertically, horizontally? What's the benefits and drawbacks of each? And in particular, it's important to think about what some of the misconceptions that learners might encounter during this topic and how we're going to try and prevent these from occurring. So these are just some of the things that we're going to think about over the next few slides. It's also helpful to be clear about correct mathematical terms around arithmetic, and in particular here's some properties that we are looking at here as regards addition, and it's good if we can understand and use this language with learners where it's appropriate. So learners should already be aware that addition is commutative, that the numbers can be added in any order and we'll still get the same sum. They may or may not be directly aware of the associative property of addition, but again, it's worth thinking about, or giving learners time to think about combinations of calculations within a longer addition calculation, and again, coming to the realisation that you can add them together in different pairs and you'll still get the same result. A property that we might not spend quite so much time on, and it is worth drawing learners' attention to, is the identity property, and that addition does have an identity, and that identity is 0. So if we add 0 or indeed subtract 0 from any number, that number remains unchanged. And one that's very directly relevant for integers is the inverse property of addition. So that for every real number a, there exists an additive inverse that's negative a. And when you add a number and its additive inverse together, you get 0. This is a 0 pair, and it's an important concept for learners as they move forward with negative numbers, and it's one that we'll talk about quite a bit. So when we're starting to talk about adding integers, it's important that we take advantage of something that learners generally do find straightforward. It's something humans are very good at. It's spotting and continuing patterns, and we can really exploit this ability when we are exploring numbers beyond 0. So If we think about setting up a simple sequence here, we can start with something very familiar. 1 add 4 is 5. We can represent that with concrete or materials or digital versions of those, and we're going to use double-sided counters here. The double-sided counters are yellow on one side and red on the other, and the convention is generally that the yellow side of each counter represents +1 and the red side represents -1. So here we've got 1 counter and 4 more, making 5, something obviously very familiar for learners. 1 and 3 more makes 4, 1 and 2 more makes 3, 1 and 1 more makes 2, and then we have the additive identity. 1 adds 0 makes 1, and again this is obviously all very familiar to learners at this stage. So we need to think then what comes next in the sequence of calculations, and we're adding on to 1, and the numbers we've been adding on to 1 are 4, 3, 2, 1 and 0. So next in the pattern is 1 add -1. And if we look at the sequence of the answers there, we've got 5, 4, 3, 2, 1. The only logical conclusion is that the next answer must be 0. So 1 add -1 must be 0 in order to continue this arithmetic pattern that would be very familiar to learners. We can represent this by 1 yellow counter and 1 red counter, and this is this really important idea of a 0 pair, that for every +1 that you add to a -1, you have a 0 pair, and this will crop up quite a lot. So taking that concept of a 0 pair, how can we explore further? Well, we can look at different representations of positive numbers, and in this case we've got the number 3. So this can be represented with 3 +1s or 3 yellow counters. We've got the quantity 3 there. If we introduce a 0 pair, we've not added anything into the total because what we have there is 0. So we've got 3 and 0, which still makes 3. But what we can see is that 3 can also be represented with 4 and -1. So that's a quantity of 3. And again, 5 and -2, still 3. 6 and -3, still 3. 7 and -4. Still 3. So these are lots of representations of the quantity 3, just with some 0 pairs included. Now this flexible understanding of how 3 can be represented can be quite handy when we're illustrating integer arithmetic. So when we move on to adding and subtracting integers, so if we're doing a very simple calculation, 4 subtract 3, learners are familiar with this. They should have 2 views of this. They could think of it as having a quantity of 4 and removing 3. And that would leave them with 1. That's something they would be very familiar with. But they should also have an idea of difference as well. So the difference between 4 and 3, or what would they need to add on to 3 to get to 4? And again, the answer is 1. So there are 2 models for that. And if we're using counters like this, probably the easiest way to do it is using that removal method there. We can remove 3 counters and we're left with a total of 1. We can explore a different calculation, and that's, well, what does 4 and -3 look like? So we've got 4 +1s and 3 -1s there, representing that calculation 4 add -3. But if learners are familiar with the 0 pairs, you can see that we have a 0 pair there, so that can go, we've got a 0 pair there, we've got a 0 pair there, and it's hopefully easy for learners to see that 4 subtract 3 and 4 add -3 gives you the same result. In both cases, the answer is 1, so those are equivalent calculations. If we look at subtracting negative numbers, what could that look like? So again, learners could have 2 different views of subtraction. They could think of it as a difference model. So again, what's the difference between 3 and -2? So that could be represented on a number line. What would I need to add on to -2 to get back up to 3? And I'd have to do 5 jumps. So the difference between 3 and -2 is 5. So if you were doing it on a number line, that's the way that you could represent that calculation. But we can also use counters to represent that takeaway model that learners are also used to. Or we would if we could look at the 3 and go, well, how could we remove -2 from that? And here's where this flexible view of what 3 can look like comes into play. If we introduce a couple of 0 pairs, we still have an overall quantity of 3 there, but it's just been represented with 5 positive 1s and a -2. So now we can see how we can actually remove that -2 and leave us with an answer of 5. So that same answer that we got from a difference model, we can actually get from a takeaway model as well if we introduce these 0 pairs. And then we can look at how that can be written as an addition, and it's 3 add 2 is +3 and 2 more, making 5. So what we've got here is that in both cases, on the previous slide and this slide, we've rewritten a subtraction as an addition, but we're adding on the inverse of the original number. So here we were subtracting -2. That can be rewritten as an addition of the inverse, which is +2. So we're going to add 2. So we've got equivalent calculations here. Any subtraction can be rewritten as an addition of the additive inverse. And it's useful for learners to be able to rewrite these subtractions and think about it in this way.
You might be interested in this lovely little activity. Jonathan Hall's brilliant website, MathsBot, that we talk about all the time, he's put a whole bunch of new things on it recently. So if you haven't been on MathsBot for a wee while, a few weeks, have a wee look, because there's some really lovely stuff on it. And this is one of his new activities. It's a directed number activity, which is precisely this. It's taking subtractions, rewriting them as additions of the additive inverse. It's how do we say these calculations, what's the equivalent addition and subtraction, how can we represent this? We're using double-sided counters, and what's the answer? And they fill in the blanks and off they go. So a really nice little activity that you might find useful with your learners if you're about to do or going to be doing relatively soon some integer arithmetic. Again, just coming back to this, sort of formal mathematical language, we've talked about commutativity and associative property as well, the identity property and the inverse property. Obviously, those 4 have an equivalent with multiplication. There's the additional one there about the distributive property as well. But for all of these properties that we had for addition, we've also got them for multiplication. So again, just trying to bring a little bit of mathematical formality where we can, where it's appropriate with our learners. We've got this idea of an identity for multiplication, which is 1. If you multiply or divide by 1, you have the same, you get the same answer, it's unchanged. And similarly, there is a multiplicative inverse as well. So the inverse of 2 is 1/2 or a half, and so on. So we've got the same idea here, that subtraction can be viewed as adding the inverse. Division can be viewed as multiplying by the inverse. So division by 2 is the same as multiplication by a half. That's a piece of understanding that we want learners to get to, so that they don't view finding a half of something and dividing by 2 is something different, and they don't miss out that idea that finding a half of something is the same as multiplication by a half. I think that's a wee subtlety that a lot of learners just kind of miss out on. So if we can be really explicit about it, that can help them gain that sort of understanding. So we're going to just quickly look at multiplying and dividing integers as well. And I certainly find multiplying integers is something that learners kind of pick up really, really quickly. It tends to be quite intuitive. If you actually said to them, what do you think 3 times -2 is? They'd probably tell you it was -6. The question is, would they be able to articulate why that is the case? Or would they just revert back to a rule that's a positive times a negative? Would they actually be able to kind of tell you why? And as we're introducing this, it'd be really good to go back to the understanding and visual representations that they did when they first learned about multiplication, which is likely to have been arrays. So if we want to represent that 3 multiplied by -2 array, we can do it like this. We've got three groups of -2 there, 3 rows of -2. Learners should also be dead familiar with this idea of commutativity in arrays, but basically if you've got the array that way, you can just swap it to that way and you're representing the same calculation in a different way. So 3 2s, 2 3s, same calculation really. And in the same way here, we've got 3 lots of -2. Learners can see that that's 6 -1s, so we've got -6 there. But they could also view that as 3 lots of -2 as well. And so we've got this idea of two slightly different but connected calculations. So this isn't just it being commutative. This is about the signs of those numbers changing as well. But actually that one array represents 3 lots of -2, but it also represents 2 lots of -3. Same idea here, 4 lots of -3 can be represented in an array like that. We've got 12 -1s, so the answer is -12. And that could also be represented as 3 lots of -4 as well. So we've got slightly more complication on the commutativity here of what those particular arrays represent. But it's maybe just nice to give the learners just 5-10 minutes to play about with that idea and think about how they can represent multiples. So multiplication, dead easy to represent in arrays where one of the numbers is negative and one of the numbers is positive, because we can effectively go back to this idea of repeated addition. So 3 lots of -2 is a -2 and another -2 and another -2, which makes -6. So that's all fine. The question is, how do you then represent that if you've got a negative number times a negative number? And that's not nearly so intuitive. It's going to take a little bit more scaffolding, a little bit more thinking about why that is. And I think in this case, we really need to go back to our patterns again. So if we go to our patterns, we can see there that 3 -1s is -3. We've got 2 -1s is -2. 1 -1 is -1. No -1s is 0. So this is the sequence of calculations here. We've got 3 of them, we've got 2 of them, if we've got 1 of them, if we've got none of them, what's next? Well, the next calculation here has to be -1 times -1. So that's the next in the sequence of calculations. The question is, what's the next one in the sequence of the answers there? So the answers go -3, -2, -1, 0. And again, learners immediately are going to spot that pattern and go, well, the answer has got to go there. It's got to go to 1. That's the only place it can go. So this extension of the patterns, an extension of the arithmetic that they already know, always building on what they already know. And the thing is that all multiplications that are a negative number times a negative number, they basically all come back to this basic fact that -1 times -1 is 1. And anything, they can justify any other calculation if they come back to that. So this might be something that you might be able to do with learners. They might just immediately sort of accept this as a logical continuation and become quite happy with it. But if you want to look at it in a bit more detail with a little bit more rigour, we might try thinking about a more complicated calculation like -2 times -5. Learners might just go, oh, that's 10. Yes, but why is it 10? Why, how could you justify why that might be 10 without going back to a pattern and continuing on with a pattern? Well, we already know that 2 -1s is -2. We already know that 5 -1s is equal to -5. So instead of just having the numbers -2 and -5, we could write our -2 as 2 -1s. We can write our -5 as 5 -1s. And then we can see that actually the bit about the answer being positive, it doesn't even matter about the 2 and the 5. It matters about this basis that we've got a multiplication of -1 times -1 in there. So what we have there, we can do our 2 times 5, that's the 10. Our -1 times -1 gives us our -1. And we know that -1 times -1 is 1. So we've got this calculation here. So if that's something that you could do with learners, and that's starting to get this idea about how can you have a bit of a mathematical justification why the answer is what it is. That might be, a bit of a challenging step for some learners, but it is something that you can go into if it's appropriate for your learners as well. And then if we're looking at division, Again, some division calculations are very straightforward to justify. If you look at the last one, -6 divided by -2, why is that 3? Well, we could go right back to our arrays, and we could go right back to our very simple understanding of division as a how many of them are in that. So if we are doing -6 divided by -2, we are asking the question, how many -2s are in -6? So we've got -2 and another -2 and another -2. We have 3 of them. So it's quite intuitive, I think, as to why -6 divided by -2 is 3, because we can think of it as how many of them are in that. Perhaps slightly harder to justify and explain is why is 6 divided by 2 -3? Well, if learners understand the link between multiplication and division, they can just again go one step back about what they already know. If I want to know the answer to 6 divided by -2, I need to think, well, what would I need to be multiplying back up by to get back to 6? So if I take my -2, what do I need to multiply back to get 6? What do I need to multiply by to get back to the 6? And it's -2 times -3 that gives me 6. And so that's why 6 divided by -2 is -3. And so it's that link back to what they've just learned. They've learned that -2 times -3 is 6. So therefore, they've also learned that 6 divided by -2 is -3. And they've also got 6 divided by -3 is -2. Now, one of the things we talk about in our PLR is little families of calculations. So for example, I know 2 times 7 is 14. So I also know that 14 divided by 2 is 7. I also know that 14 divided by 7 is 2. I also know that a half of 7 is 14, and a half of 14 is 7, and I also know that a seventh of 14 is 2. So we've got these kind of families of calculations that go together. So it's maybe worthwhile giving learners a chance to just put families of calculations down together here as well. If I know -2 times -3 is 6, then I also know what 6 divided by -2 is, and I know what 6 divided by -3 is. That should be something that's familiar to them if they have a good understanding of multiplication and division. So again, rather than just focusing on the kids coming up with a rule, positive divided by negative is negative, negative divided by positive, you know, let's just get them to just pause and consider, well, what is it, and how could you explain to me why that is? Not just because a positive divided by a negative is a negative. Yeah, but why? Why is that? Can you draw it? Can you explain it? Can you use a different calculation to sort of come up with this one? What is it that you know? Why is it what it is? And I think that's really important for learners in this, that they don't just blindly learn the rules here. I'm just looking here. We've got teaching negatives next. I've written down in anticipation to the but why questions. It's it is important about having an answer for the but why. What do you notice? Few examples. Humans do love a pattern. Yes, thanks, Stephen. They absolutely do. They just, you know, if they can see it for themselves, that's really, really helpful. Can get their own understanding of what's going on there. So why is all this really important? Well, when we start collecting like terms, it's helpful here, and see if we look at this first example. Apologies if anybody struggles to see green and red. This one's in green and red here, but if we have our 3x and our -5x, if we have an understanding of 0 pairs, we can see that we've got 3 positive x's and 5 negative x's. So we've got 3 0 pairs there and an extra -2 x's. So that's why that resultant term is -2x. So that kind of familiarity and understanding of those 0 pairs may well help learners immediately move on to collecting like terms with negatives quite happily. You can also get double-sided algebra counters on MathSpot as well. So this is x's, and on the other side red x's and y's in a different colour and red y's, and those can be the positive and negative x's and y's that might help them model those situations if they need a bit of support, a bit of scaffolding for collecting like terms. The additive inverse and the multiplicative inverse, absolutely critical to how we teach solving equations. So if we have, as we can see in this middle example, we have a +7. If we're wanting to simplify that equation, then we are, in order to sort of remove that add 7, we need to do the additive inverse, which is subtract 7 or add -7. And so we're doing that to both sides of the equation, so it stays balanced. And then we've also got the multiplicative inverse there as well. We have a division by 5. The inverse of that is a multiplication by 5. So these inverse operations, really, really important that learners have a good understanding of that. A bit more on the zero pairs when we come to simultaneous equations by elimination, that third one there. You can see in the first sort of pair of lines of working, the first couple of blue lines there, got a lovely zero pair sitting there. We've got a -6y and a +6y. That's a nice big zero pair. So when we add the equations together, we get 0 for that bit. Some learners find that really difficult, and I think it's if they don't have that understanding of a zero pair, if they've seen that lots before, they shouldn't view that as anything new and different. It's just an extension of what they know already again. So a bit of simultaneous equations. Again, we've got to be able to deal with integer arithmetic when we're dealing with indices as well. Be really confident about subtracting 1 from a negative number and that kind of thing when we're doing calculus as well. That can cause a whole ends of difficulties. And then obviously when we're working in coordinates in 4 quadrants, again, there's lots of calculations that we end up doing involving negative numbers, and it's usually working out the difference between the negative numbers if they're doing gradient, or they're working out the distance between 2 points. It's that difference between either 2 negative numbers or a positive number and a negative number. We want that to be really fluent and really accurate, so learners can move on to using that to do stuff later. So that's why it's really important, and if we can get them really confident and fluent and really good level of understanding in integers, it will save us so much time and angst at a later moment. So please do, as I say, this isn't a gospel of how this can be taught. It's about thinking about what way is going to suit your learners best, and some ways to scaffold the understanding and develop understanding so they can move on to becoming fluent. If you're wanting a bit more information about negative numbers, loads of sites there. There's the Craig Barton interview with Bernie Westacott is excellent for looking at using concrete materials for negative numbers. I think it's a sort of 40-minute session, really worth watching. There's lovely stuff on Enrich. Some research, and also the NCETM materials down from the Centre for Excellence Teaching Maths down in England. There's lots of stuff there on using concrete materials as well. That's a brilliant site as well. So lots more things to go away and check out there. Okie dokie, I think that's me done. We're over to Stephen now just to finish off the session, looking at bits and bobs to do with 4th level and rounding us up. Thanks, Stephen.
Very much. Iona, folks, I'll just have you a wee minute to have a read at that, catch a breath and have a wee read. That is an extract from our professional learning resource for number and number processes. Now we've put in the bold, unfamiliar and across the curriculum. Because even with no new explicit content at 4th level, we know that our learners need to and will continue to practice and apply their skills in number in our subject and across the curriculum. For example, in their STEM subjects or financial education. So it's important what we consider what opportunities that we can provide, perhaps within our department and maybe in partnership with other teachers across the school. That includes maybe extracurricular clubs or leadership of learning through Maths Buddies programmes in your departments, through taking part in competitions and other regional, national or international events. So as Iona says, always building upon what the learners know and letting them apply it means that they can practice those skills that are really integral to the senior phase. Thanks, Iona. I think you're still on slides. Thank you. Within our professional learner community, which is on Glow, you'll find a collection of links to activities and other resources. You'll see in the top left there, within the Learning, Teaching and Assessment section, there's a Developing Mathematical Thinking tile, which brings together different websites with some great tasks and materials, including what we're using tonight. A key thing worth thinking about is that tricky problems don't have to involve what some might call tricky maths. Those number skills can be applied through different contexts and using different problems. It's about encouraging our learners to really think deeply using the 4 operations. It's important for differentiation and challenge. We know how difficult or challenging it can be to manage a whole class. It means you don't always have to move on your more confident learners to a new topic. As Mr. Melrose pointed out in the chat, he can see how you might use always, sometimes never true to support his fast finishers. And it also means you don't have to shield your less confident learners from thinking hard, because you can always encourage them to have a go at these activities. We see here a little task from Enrich, negative dice, which some of you are saying you're going on to integers, so that might be useful for you in the links there. Thanks, Iona. I'm just conscious of the time, Iona. The next one here is a lovely activity from Don Stewart. And again, that's just using the 4 operations. You can see all the different questions that you can challenge. You can see how you could use that with individual learners or in pairs or in small groups. So again, it's building upon what you're teaching them. And once you finish your exercises and they've done the homework and all the rest of it, it's these little activities that can continue through retrieval or through continued practice, or by even creating their own problems, that they can learn how to apply these skills. Iona, the next one, if you just put it up for me, is open middle. It's a lovely problem. Mrs. O'Donnell said that she uses open middle for that, for encouraging thinking. They are absolutely brilliant. Sometimes the open middle problems that can all kick off because people think they've got the answers, and then all of a sudden someone comes in with a different answer, or a better answer, so to speak. So they're really, really good. That's linked to their PLC. And the final one we like to show you just now is Math for Love. Math for Love, an American teacher. It's got really nice short activities which you might find useful for starters, or little transitional thinker tasks as you move through different parts of your lesson. And again, you might use it for homework. It might be a little lunchtime club you do, or little paired activities if you're wanting your younger pupils to develop within the math, become part of the math department by working with more senior pupils. Thanks very much, Iona. We've got all the links. I know we put them in the chat, but as Iona says, the chat does disappear. So within this presentation of the PDF, you'll see that we've got a link to the Padlet, and within that you'll see a link to the car park Padlet for any questions or comments that you've got that you'd like others to comment on before the next session, or like us to come back to. There's also going to be a link to the videos and the slides for this presentation, and perhaps the primary ones as well, but they'll certainly be put up onto the regional teams. It's a really comprehensive set of links, and I'd recommend that you save it into your bookmarks. Thanks very much, and I'd like to just hand over to Nanette, who's going to round off today's session. Thank you.
Thanks, Stephen. Just before we finish off, just to go back to the car park, there is a question that's come up around today's session relating to using manipulatives and trying out some of these things we've been suggesting. And the question is around, what do you do if you get the response, "Oh, miss, can I not just do it the normal way?" When normal usually means standard algorithm, column addition, etc. Oh, the question's just disappeared. Oh, it's moved down there. So the question is, what do you do? Do you persist with this alternative, or stick to what they're confident with? I've got to say that I would keep trying to win them over. I would use digital manipulatives in my introductions and as part of my teaching, and try to drip it in. I know that there is resistance from learners that feel as if they're being put in a step backwards, but if you can keep going and they can just find a little nugget that actually gives them a bit better understanding, then they may eventually come round. There's obviously a point where you're not going to push it, but I would keep trying. That's my personal opinion. I don't know what you think, Iona.
I would definitely agree with that. I think it's about how you introduce it, that you're introducing both the kind of abstract notation, but with the visual representation, whether that's with the counters or tiles or whatever it happens to be. But sometimes what you have to do is reframe the task. So the task isn't expand these brackets. The task is, can you demonstrate using... So you effectively give them the answer. Can you demonstrate using algebra tiles why the solution to this calculation is that? So you're not asking them to find the answer. You've given them the answer. And what you're actually asking them to do is demonstrate it using the visual representation or some other representation. So they can't say, can I do it the normal way? You're saying, I've done it for you. I've told you the answer. I want to see why that is the answer. Can you show me why that is the answer? It's
about giving them that opportunity to articulate their understanding using a particular tool. So I think it's worth persevering, definitely worth persevering, and I would certainly use it in demonstrations and use it in examples, because somebody somewhere within that class will probably appreciate it. Stephen, thoughts? Would you?
Yeah, I mean, I think my only thing to add would be to make it part of your norm. And I know I'm we're NQTs and early career teachers here, but as you continue in your career, you're going to see the kids from S1 to S6, and some of you are going to lead departments. You make it part of your normal learning and teaching it, and as Nanette, I want to say, you put it into your starters, you drip feed it into your practice. We're not, especially as we move into the 21st century, you don't have to go away and make lots of concrete materials, but if your department has those kind of things, you make them part of the learning kits. You've got your textbooks, your rulers, your pencils, and the materials are there, and you'll probably find that your learners start to come round. And saying that though, as Nanette says, don't feel the need to flog a dead horse with them. If the understanding's there with what they're doing, that's absolutely fine. But remember, when you shut the door, it's your little kingdom, so you can encourage them to use it.
And in the end, the goal is procedural fluency and abstract thinking. But it may well be that, if you've got algebra counters or algebra tiles that you're using, the learners prefer to draw them instead of using the concrete materials, and that's absolutely fine. And I was saying to my colleague, we were looking at the double-sided counters earlier, and they might start with yellow and red circles, and then it goes to a circle with a positive or a negative in it, and then the circle disappears, and you just get this.
It's just positives and negatives.
And then it disappears completely because at that point they don't need it anymore, and that's absolutely fine as well. I think it's nice if it's inbuilt into the task. So, for example, that MathSpot task with the direct the subtraction and addition of a negative, addition of an inverse, the double-sided counters was just part of it. And so it was a requirement of the task, and I think that's helpful. And it might well be that you're only doing one or two examples like that at the beginning to check understanding, and after that what they're doing is using the scaffolding as much or as little as they need it after that,
But I also think, the more times you introduce it, then it's useful when you come back to the next stage, because they may not particularly need it at that point. They may be fluent, they may be able to do without scaffolding, but if you've used it and you've demonstrated it and you've used it as part of your explanation, then when you move on to that next stage, you can reintroduce it, and at that point it might be that there's one or two that think that's actually quite a useful bit of scaffolding. So I do think it's worth just persevering, not getting tied up and concerned that if not everybody is making use of it, but keep trying, keep putting it just within your everyday teaching. Yep. There is another big question, and I think that may be one to return to at a later stage. I don't think we've got time to investigate that this afternoon, but it's around how to engage disengaged students, how to make them love maths and see its beauty. Initially, I would say doing all the things we're talking about, using the different tasks, being enthusiastic, using different approaches is a start. and hopefully that will grow over the session. You'll get more and more ideas to, I think if you show your love of maths, and that helps, but obviously it's not the answer to the most disengaged. So that's maybe some.
Yeah, I would also say build their confidence. Really build that. If anybody's really disengaged, it's probably one of two things: either they have their confidence is at rock bottom, or they're not being challenged. So they're kind of two extremes. So I would try and figure that out. And if they're not confident, really work on building that learner's confidence. And the more confidence they have, the more success they have, the more engaged they'll become. But similarly, if they're not engaged because they've not, they don't feel they're being challenged, then find something, one of these learning activities that we've got, that we've suggested, one of these sites. There will be stuff on there that will really make them think, and hopefully that will give them some impetus into that as well. And about building relationships, just talk to them, try and find out why they're not, what's the problem, that kind of thing as well. But please do, any other ideas, please add comments to the Padlet, please. Hopefully you can. I know somebody's put a like on one of them, so I'm hoping that you're able to add a comment. Maybe somebody could just try and add a comment, as long as we've set it up okay, the permission's okay, that you can actually add comments onto others. Please add comments onto them to add your ideas to these big questions over the next, between now and the next session. That would be really good. And please, any other ideas, suggestions that you have that you want to share, please do pop them on.
There's a shared resource there. That's something else that would be useful, maybe just to add to the car park, because as I say, that link will disappear at the end of the meeting tonight. So if you wanted to share that on the Padlet, that would be great. Now, I'm aware that we are coming towards the end. Just a couple of things to round off. As always, we'd like you just to reflect on this afternoon session, and think about, the main point you're going to take away from the session. Some people have already shared something that they're going to do right away. And also to think about something that they fancy learning a bit more about. And we've put some links in there for some extra reading and for some further investigation, because we've only scraped the surface tonight. We could probably have done the whole 9 sessions looking at some of the different areas of number and number processes. So there's lots more to investigate. So just a reminder as well about the regional groups. The codes are there again for you. You'll be able to access them through the slides on the Padlet. The next session is on Tuesday the 9th of November, so not too big a gap. We've then got a further session in December, and that's will be the last one before Christmas. So the session on the 9th of November focuses on fractions, decimal fractions and percentages. QR code is there, and the webinar registration is there as well. So please sign up. It doesn't ask you as many questions as the first one, but it just helps us to keep on top of who's signing up. I have contacted people that signed up in the first one. You're on a list, so you may, even if you don't register, get a bit of communication from us, maybe asking if you'd like to come along, or why you can't make it, or whether you want to be taken off that list. So finally, 2 or 3 minutes left. Your microphones are now enabled. You're all on mute, but they are enabled. So if anybody would like to come in and ask a question, then please feel free to use the hands up function, and we'll invite you in. If there's anything you would like to share or any comments you would like to make. Otherwise, then I would just like to say thank you for joining us this afternoon, and I hope that you have an enjoyable evening.